In our final exercise, we are going to use the idea of double buffering in order to prevent some of the flicker that we saw in exercise 7. You may not have seen a lot of it. A lot of the newer and faster computers can process those background processes so quickly it looks pretty seamless. But one other way to deal with that flickering effect in animation is to, while you're displaying the current picture, draw the new picture off the screen, and then that way when and then swap the pictures out. Swap the pictures you're displaying out. So if we look at this applet that we saw, what we have here is we have a game essentially. It's a race. We click the go button and we look to see which comes first. Notice there's very little flickering. There is some hesitation in the movement. The movement's not real smooth, and that's going to be because those background processes are pausing to give time to other processes. But that's not a big deal. The other thing that we see here is that we're implementing two interfaces. Again, you're allowed to do this so long as you have code written for every method in each interface you're implementing. That means for action listener, we have to have an action performed method, and for runnable, we have to have a run method. I've got quite a bit of code in here, and let's take a look at it. First of all, I'm creating a couple of items right off the bat. I'm creating two integers, position 1, position 2. I'm creating a buffer a buffer, something to hold a graphics object called buffer. I'm creating an image object called offScreen, and this image holds what is written in the background away from the screen. It gives you sort of a canvas to draw on rather than using the canvas of the screen. We're also declaring a thread called runner and a button called go. In our initialize method, we're going to use the flow layout. We're going to set the background to be yellow, and we're going to create a go button. Tell it that we want to listen to events from this button, and add the button to the window. We're going to set up off-screen by calling the create image method, and we're going to provide it a width and a size. And what that does is that allows us to, this is going to be again our sort of canvas that nobody sees while we're working on it, rather than drawing on the canvas that is the screen. And what's nice is we can call the get size method that comes from JApplet that will tell it how big our applet window truly is, since we won't know that until the HTML runs. Once we have this image, essentially the same thing as the screen, we can call getGraphics, and that will get the graphics object for that picture or that canvas. So we can start, remember I said the graphics object is like the paintbrush. We can now get the paintbrush that goes with that canvas. Then what's going to happen is the run method's going to be called. While I've decided that the racetrack for these two items is going to be 300 pixels long. So while they both are not at 300 pixels, while they haven't moved at least 300 pixels, we're going to keep trying to move them. And how we do that is basically take their current position and add the result of move ink. Well, if we look at the move ink method, all it does is get the highest integer value lower than math.random times 5. So all that does is ensure that if we get a decimal number, that we are going to come back with the highest possible integer number that is less than the result of 5 times math.random. We're going to make sure that is an integer, and we're going to send that back. So essentially we're adding this random integer to our position. Once we get the random integers for our position 1 is for one ball, position 2 is for the other, we're going to have our thread sleep for essentially 15/100ths of a second. Then we're going to call the repaint method. The repaint method actually calls the paint method. The paint method, essentially what we're going to do is we're going to write the graphics buffer to create the new screen. So we're going to create a clear rectangle. We're going to set the background red. We're going to fill an oval, or we're going to create a clear rectangle. We're going to set our color to red. We're going to create the red oval at the position that we have calculated below. We're then going to set the paintbrush color to green. We're going to create a green oval at the location that we've picked. We're then going to test for the winner. So if we then discover that position 1 is greater than 300, then position 1 has won the race, and so we're going to call the draw string method to print out in black red wins. If position 2, which goes to the green circle, is greater than 300, then green has won. And we're going to print that out. We're going to draw that on the screen as well. And then finally, when we're finished drawing this buffer, we're going to call the draw image method and provide it that off-screen object, that image object we created behind the scenes, behind the curtain, if you will. So essentially we have what's on the monitor currently being displayed, and we're drawing the scene in the background. We're creating the rectangle, painting the balls on it, painting the message on it if we need to. And as soon as we're done with that, what we're going to do is take the current image and we're going to throw it away, and we're going to bring a new one in and show it to the user. And we're going to do that so fast. Again, it's just like taking those pictures of those cells in the old school Bugs Bunny cartoons, where they animated each individual cell to show each animation and then displayed the pictures in rapid succession. You could also think about a little flip book. The Eaton Park used to give out these flip books with the Eaton Park star, and if you flip through them fast enough, it looked like the star was bending down, the tree was bending down, picking up the star and standing up again. Again, what was happening is we were seeing those pictures, we were displaying those pictures in rapid succession. Additionally, we're overriding the update method here to prevent the update method from clearing the screen. Anytime we change the screen, the update method gets called and clears out the current contents of the screen. This is what causes the flickering, so we're going to prevent that by just saying, just call the paint method. Action performed is for our button, our go button that you'll see on the screen again in just a moment. And when the go button is pressed, we're resetting the positions to 0. And if the thread is null, we are starting a new thread. We are creating a new thread object and starting it. And again, if we take a look at this, if we take a look at what's going on, let me bring this down here. We have this go button here. We click the go button, and we start to see them move depending upon which process gets more time, and what random number comes up when that process gets time. Every time we get a new random number, we redraw where the red and green circles show up. Again, we don't see any flickering here. The movement's not real smooth, and that's going to depend on how fast the system gets back to the process. It may run that process a few times and then stop and then do something else, and then let that process run some more and then stop it and do something else. But that is what we can do with processes and background processes and animation. And background processes play an important role in a lot of things. If you're doing large file transfers, one of the things you can do is have that file transfer in the background and provide some sort of status bar. Anytime you need to provide statuses while allowing the user to do something else or the application to do something else, threads come in very handy. Multi-threading is something that I find that I use on numerous occasions to specifically to display statuses to users, and I find it very useful for that. This concludes CIT 130. And I hope that you enjoyed this course. I hope that you got some good information. There will be a short quiz associated with this lecture. However, there is no homework assignment. Thank you.